Good morning, students. Today we will do the next two another type of quadrilaterals. First is kite. Kite. What is a kite? A quadrilateral in which the two pair of adjacent sides are equal is known as a kite. So two pair of adjacent side means AB is equals to AD and BC is equals to CD. So this figure is known as kite. And the second property of the kite is that the diagonals of the kite meet each other at 90 degrees. Second type of the quadrilateral is trapezium and the isosceles trapezium. What is trapezium? A quadrilateral having two parallel opposite sides and two non-parallel opposite sides is called a trapezium. Like in this figure you can see AB is parallel to DC and AD is not parallel to BC. So this figure is known as trapezium. And what is isosceles trapezium? So isosceles trapezium is same. If a non-parallel sides of a trapezium are equal, then it is known as isosceles trapezium. So first thing, PQRS is a trapezium means one pair of opposite side will be parallel and the other pair will be non-parallel. But if non-parallel sides are equal, PQ is parallel to SR and PS is equals to RQ, then this is known as an isosceles trapezium. Second property of the isosceles trapezium is that angle P is equals to angle Q and angle S is equals to angle R. Now next we will do the questions which is based on trapezium as well as on kite. So we will start with the question which are based on the properties of kite and trapezium. So first question number 9 is ABCD is a kite whose diagonals intersect at O. If angle DAB is equals to 54 degree and angle BCD is equals to 76 degree, calculate angle ODA and OBC. So first we'll see ODA angle is which one? This is ODA. We will give the name angle 1. OBC, this angle, so we'll give them a name angle 2. So we will use the properties of the kite that their adjacent sides are equal. So DC is equals to BC and AB is equals to AD. So AB, we'll write down here, ABCD is a kite. Therefore DC is equals to BC and AD is equals to AB. Now we will consider the triangle DCB. We can see the two sides are equal. So it becomes an isosceles triangle. So in isosceles triangle, if sides are equal, their opposite angles will also be equal. So give the name angle CDB as angle 3. So DC is equals to BC. This implies angle 3 is equals to angle 2 because sides are equal, so their opposite angles are also equal. This is a property of an isosceles triangle. So we'll suppose let both the angles is equals to x. Therefore, we will use angle sum property now. Angle C plus angle 2 plus angle 3 is equals to 180 degree. Angle sum property of a triangle. So angle C is 76, x plus x is equals to 180. So 2x is equals to 104 and x is equals to 52 degree. So angle OBC is equals to 52 degree. This is the first angle that we have to calculate. Now we will see to the second triangle. So in triangle ADB also, AD is equals to AB. This implies again by isosceles property angle 1 is equals to angle 4. The reason is same because sides are equal, so their opposite angles will also be equal. We will suppose let both the angles be y. So we will put the value now in angle sum property of the triangle. 54 degree plus angle 1 plus angle 4 is equals to 180 degree. So 54 plus y is equals to 180 degree. This implies 2y is equals to 180 minus 54. So y is equals to 63 degree. Therefore, angle ODA is equals to 63 degree. Now we will move to the next question, which is based on an isosceles trapezium. ABCD is an isosceles trapezium in which angle CDA is equals to 2x and angle BAD is equals to 3x. Find all the angles of the trapezium. So in an isosceles trapezium, we know that the two sides are equal. Two non-parallel sides are equal. So AD is equals to BC and angle A is equals to angle B and angle D is equals to angle C. So this is the property of an isosceles triangle. Angle B is 3x and angle C is 2x. So now first we have to find out the value of x. So there are two ways to find out the value of x. Either you can use sum of all the angles of the quadrilateral is 360 degree, or you can say angle A plus angle D is equals to 180. Any one of the property you can use. So I am using angle A plus angle D is equals to 180 degree. That is co-interior angles. 3x plus 2x is equals to 180 degree. So value of x is 36. So rest all the angles will calculate by putting the value of x. So angle A and angle B both is equals to 3x. So 3 into 36, that is 108 degree. Similarly, angle C is equals to angle D. Both will be 2x. That is 2 into 36. That is 72 degree. So these are the values of all the angles of an isosceles trapezium. See next question number 15. ABCD is a parallelogram and PQBA is also a parallelogram. So they have given two parallelograms. We have to prove that DPQC is also a parallelogram and DP is equals to CQ and the triangle DAP is congruent to triangle CBQ. So again children, we will prove any one of the property of the parallelogram. Either the opposite sides are equal and parallel or the opposite sides are parallel. So we'll start. First we will see in parallelograms ABCD and PQBA. So first I'll see ABCD. AB is parallel to CD and AB is equals to CD. Similarly, in parallelogram PQBA, PQ is parallel to AB and PQ is equals to AB. The reason for both the equation is because opposite sides of a parallelogram are equal and parallel. This is equation number 1 and 2. So from equation number 1 and 2, we can see that PQ is parallel to CD and PQ is equal to CD because AB is the common side. So we have proved one pair of the opposite sides is parallel as well as equal. Therefore, PQCD is a parallelogram because here again we have proved opposite sides are parallel and equal. So now if PQCD is a parallelogram, so we have proved PQCD is a parallelogram, therefore PD is equals to CQ. Both the sides are equal. Now the last part we have to prove the congruency of these two triangles. So DAP and CBQ, as we know that ABCD is a parallelogram, so AD is equals to BC. Second, AP is equals to BQ, again opposite sides of a parallelogram. And the third we have already proved, DP is equals to CQ. So all the three sides are equal. That means these two triangles will be congruent by SSS axiom. So here now we will prove the congruency in triangle DAP and triangle CBQ. First, AD is equals to BC, AP is equals to BQ because opposite sides of a parallelogram are equal and PD is equals to CQ proved above. Therefore, triangle DAP is congruent to triangle CBQ by SSS axiom. So, hence proved. Now see the last question for today, question number 16. ABCD is a parallelogram in which BM is perpendicular to AC and DN is perpendicular on AC. Prove that triangle BMC is congruent to triangle DNA and BM is equals to DN. So for this, we will consider these two triangles. In triangle AND and triangle BMC. First condition is AD is equals to BC because opposite sides of a parallelogram are equal. Second is angle N is equals to angle M because both are perpendicular, means they are 90 degree. Third is angle 1, and let this angle is angle 2 as both the lines are parallel. So these angles are alternate angles. Angle 1 is equals to angle 2, alternate angles. And therefore, triangle AND is congruent to triangle BMC by which axiom? Now we can see two angles and one side. So by AAS axiom, the triangles are congruent. So if triangles are congruent, that means DN is equals to BM by CPCT. So hence proved. So children, based on today's concept, just practice question number 10 till question number 16. Thank you.